So the question says, I have a circle with a radius of 10 and the origin is 2, 4. First, we have to determine the equation. The universal equation is I have x plus or minus h squared plus y plus or minus k squared is equal to r squared. This is the universal equation where h and k is a shift of the origin. So in this case, the origin is not 0, 0. If I were to draw this, my origin is 2, 4. My origin's up here, 2, 4. And then the radius is 10. So I have my circle up like that. And the radius is 10. 10 units long. So the general equation will be, I need to shift to the right. So x, if I'm going to the right, you have to do opposite operation. You need to minus 2. Because it's inside the bracket. And so it's going to be the opposite way that you think. Because when you're solving for x, if you solve that equal to 0, therefore x is equal to plus 2. And that will shift x 2 units to the right. So it's going to be x minus 2 squared plus y. We need to shift y up 4 units. So I'm going to minus 4 squared is equal to r squared. R squared is 100. So this is the answer for the very first question A. The equation of the line is going to be x minus 2 squared plus y minus 4 squared is equal to 100. Let's verify that this is correct. We can go into Desmos. Okay. Oh, let me find Desmos. I'm going to go x minus 2 squared and then y minus 4 squared is equal to 10. You can see that my circle is up here, the radius, the center is there, and the radius that. So that is correct. Now, the second part, B, we need to determine if a point is in, on, or outside using over here from our last previous in the class. So to do that, you can just put in your x and y values. Here's my x and y values here. So I'm going to have 3 minus 2 squared plus y, which is 6 minus 4 squared, is equal to 100. So we're going to have 1 plus 2 squared. It's 1 plus 4. Does that, what is going on? So this is 5. Now, previously, look at right here. This 5 is less than 100. 5 is less than 100. So if our values here is less than r squared is 100, then it's inside. Therefore, P 3, 6 is inside the circle. Let's verify that this is working using Desmos. Okay. I'm going to add a point. 3, 6. And what's called, I don't know. How do we put a point in Desmos? 3, 6. Ah, there we go. So you can see right from our graph here that the point is indeed inside. And you can play around with this kind of idea. So there we go. I hope this was helpful.